All right, in this section, we're going to talk about negative exponents. So let's go back to our example we talked about earlier using a base of 2. If we raise 2 to the 4th power, we get 16. And if you remember, every time we go down a power, that number gets cut in half. So we use this to demonstrate that anything raised to the 0 power is 1. Well, now if we jump into the negative exponents, we continue that halving. So now we're going to go into fractions here. So if you take half of 1, you get, of course, 1/2. Or another way to write it is 1 over 2 to the 1st power. And let's do one other negative exponent. Half of a half is a 1/4, or 1 over 2 to the positive 2nd power. So we keep that halving power. So you see when we get to negative exponents, we start to obtain fractional answers. So there's really two definitions of negative exponents here officially. If you have a negative exponent, you can rewrite it as 1 over a to the positive n. Or if they give you a negative exponent that's already in the denominator, you can rewrite it where it is in the numerator with a positive exponent. So in other words, if there's a negative exponent, you either move it upstairs or downstairs in the fraction to get rid of it. So let's look at some basic examples here. X to the -5th, again, we can rewrite this since it's got a negative exponent. So we can use this format right here and just rewrite it as 1 over x to the positive 5th power. And a real easy way to check it is, let's substitute a real number for x. So let's say x was 2. If you raise 2 to the -5th power, you get 0.013125. Or if you type in the simplified answer, which is 1 over 2 to the positive 5th power, we should get that same decimal. They give it to in fraction form here, but if we convert that fraction to a decimal, you see it is 0.03125. So it's a good thing to do when you're doing these problems, especially with variables, to substitute real numbers for x. The rest of these are much the same. 4 to the -2 power is the same thing as 1 over 4 to the 2nd, which can be simplified further to 1/16. Then again, you can see I've checked this one in the calculator, typed in the original problem, typed in the answer just to verify those are equivalent. And then just a couple of wrinkles here. Part C, you are raising the quantity of -3a to the -2nd power. So both of those things are being raised to the -2nd power. So that means when we rewrite this, both of them move to the bottom of the fraction. We could also simplify this a little bit further because we know that -3 squared is positive 9. And just go a little bit further with that. And then letter D is the one you got to watch out for. So letter D, you are not raising A and B, that quantity, to the -1 power. You're only raising B to the -1 power. So A, since it doesn't have an exponent, remember there's an assumed positive 1 exponent there with A if they don't give you one. So A stays in the numerator and B goes to the denominator. If you want to give B a positive 1 exponent, you can. You certainly don't have to. So it's only the base that is being raised to the negative exponent that gets moved. And just a caution, a common mistake is to think anything raised to an exponent is a negative number. Of course, anything raised to a negative number is not going to be a negative number. It's just going to be a fractional answer. So 4 to the -2, of course, is 1 over 16. We've already looked at that. And 4 times -2 is -8. So those two expressions are not equivalent. So let's do a couple examples. Example 1, you are multiplying bases. So think back to the last section. When you multiply bases, you add the exponent. So that rule from the last section has not changed just because we have negative exponents there. So I'm going to add 3 plus -5 to simplify this, rewrite this with just one base, and that ends up giving us x raised to the -2nd power. We never want our final answer to have negative exponents, so just like before, to remove the negative exponent, we're going to put it in the denominator of the fraction. So we get 1 over x squared. And again, I substituted 2 in the original problem and 2 in for the answer to verify that those expressions are equivalent. All right. So again, think back to the last section. When you raise a power to another power, that means you are multiplying the exponents. So first off, I'm going to go ahead and slip an exponent of 1 with the base of 5 there. And then I'm going to multiply all of the exponents inside the parenthesis by the 4 that's on the outside. So 5 becomes 5 to the 1 times 4th power. X becomes 3 times 4. And y becomes -7 times 4. We can simplify this just a little bit. So the only thing that has a negative exponent here is the y variable. So that means that's the only thing that needs to move to the bottom of the fraction. I think 5 to the 4th power is 625. So now this last one, we are dividing. And remember, division converts to subtraction. So you could subtract -7 minus -12 if you wanted here. But what I'm going to do is I'm actually going to get rid of the negative exponents right off the bat, which is also an option. So the -12, if it moves to the top, it becomes a +12. The -7, if it moves to the bottom, it becomes a +7. And then division converts to subtraction. It's a lot easier now because we've just got a +12 minus a +7. And we end up with an answer of x to the 5th. And again, I cannot stress enough, get in a habit of checking your answer just to verify that the final answer is the same as the original problem. Go ahead and pause the video and I'll show the answers to the 3-year turns here in just a second. So here are the correct answers for those 3. Notice on part B, I did this one a little bit differently. Since there was only one negative exponent in the problem, you could have moved that one downstairs right away, but that's the only one that would have moved immediately to make it a positive. So I went ahead and just went straight to subtraction in that problem, unlike the example we did together. All right, last thing we're going to talk about is reciprocals and negative exponents. And again, we kind of discussed this in the one division example we did together. If you've got a fraction that's being raised to a negative exponent, the first thing you can do, if you so choose, is you can flip that fraction and make the exponent positive, which sometimes may be a good strategy to use. So that's exactly what I'm going to do on this first example. Is we are raising x to the 4th and 2y to the -3rd power. So you could multiply do the power to the power rule here. But before we do that, I'm going to flip the fraction and then make that exponent positive, just to simplify things just a little bit. And then we recognize, okay, we're raising a power to a power. So it's 2 to the 1st times the 3rd. It's y to the 1st times the 3rd. And it's x to the 4th times the 3rd. And then we can simplify this to 2 to the 3rd, y to the 3rd over x to the 12th. Or we can write that 2 as an 8. Go and pause the video and see if you can do that last one. So again, this one had a little bit of a wrinkle in it with the negative number. But remember, the only thing that flipping the fraction changes is the sign of the exponent. So the only thing that changed when we flipped this fraction was that -2 became a +2. So then when we squared everything, remember there's technically a -1 right there that we're multiplying this entire fraction by. So that's where this -1 squared came from in this problem.